Hello everyone, today let's take a look at Quantipus number 45, which is another combinatorics question. It's asking how many distinct arrangements or permutations of the letters in the word Mississippi are there, and it gives us some examples, this one here and this one here. So the first thing to note is that in the word Mississippi, we have 4 S's, 4 I's, 2 P's, and 1 M. So if we sum all these up, we get 11 total letters in the word Mississippi. And we know that if we have 11 things, then there's going to be 11 factorial permutations of them. But that is for 11 distinct items. And in our situation, we have repeated letters here. And when you're permuting things that are not all distinct, it's basically called a multinomial problem. And you can think about it like this. Basically, if I take my 11 spaces for letters in the word Mississippi, and I have my S's here, and I make them distinct by calling this one S1, this one S2, etc., I1, I2, I3, I4, P1, P2, and M1, just basically notice that this permutation right here is exactly the same as this permutation if we just swap these S's because we don't care which S's are where. And this is what's getting overcounted if we just permute all 11 like this, and we have 11 factorial. So the ordering of these S's only relative to each other does not matter. And we know that since we have 4 S's, there are 4 factorial ways to permute them. So that basically tells us that for every distinct ordering like this one, we overcounted in this number by a factor of 4 factorial. So that means we're going to need to divide by 4 factorial. Now the exact same thing can be said about the i's. For all of these i's, we know that they can be permuted in 4 factorial ways because there are 4 of them, and for every distinct combination, we're overcounting in here also by a factor of 4 factorial, so we divide yet again. Now for the p's, you can see the pattern. We have 2 of them, so we need to divide by 2 factorial, and m, we have 1, so we need to divide by 1 factorial, which is just 1, so we don't even need to write that. So just to really hammer this home, I drew this diagram. This is just one distinct ordering of Mississippi, so it should count 1 time in our final answer. However, when we have the number 11 factorial, it's counting each of these letters as separate entities, so all of these are going to be counted in this number, even though they should all be the same. And how many distinct ways could we have gotten this while only switching the S's? Well, it's just the number of ways that you can permute 4 S's is just going to be 4 factorial, right? I drew a few here, right? Here I switched the S2 and the S3. It's still going to give you this distinct thing, right? I switch S3 and S1 and S2 and S4, it's going to give you this. We know there's 4 factorial ways to do it, so that's why we had to divide by 4 factorial. Now, another maybe simpler way to think about this is using combinations. Basically, we have 11 places to place letters to start, so let's just do them one by one. We have 4 S's, so we choose 4 spots for these S's. Then we have 4 I's and 7 spots remaining, so let's do 7, choose 4, and then we're going to have 3 spots remaining for 2 P's, and then we're going to have 1 spot remaining for 1 M, so there's just going to be 1, so we can just ignore it basically. So when you write it out, these end up canceling like so, and you get the exact same answer, right? 11 factorial on 4 factorial, 4 factorial, 2 factorial.